Hello, in our previous lesson we noticed that some of the dots were solid and some were open, and we tried to explain what it means. What do you think that is? If the symbol is greater than or less than, then the dot is open because it cannot be equal. If the symbol is greater or equal or less or equal, then the dot is solid because it can be that point 2. To show that it is inclusive, we make it closed. Like here, it is closed because 1 is included in the values of x. It is open because 2 is not included among the values of x. Now today we shall look at solving linear inequalities. Inequalities are very similar to equations. The only difference that you will end up with a range of values for x rather than one specific value. Now for equations, for example 2x plus 1 equals something, you will solve and get one value of x. But for these ones, for inequalities, we shall end up with the range of values, not one specific value. Let's look at. They are solved in the same way as we did equations, but the only difference, equations have the equal sign, these ones have one of the symbols that we saw in the previous lesson. Example 1, solve the inequality below and show the answer on a number line. It is 8x is less or equal to 32. What do we do here? We divide here, we solve the way we use it to solve equations. We divide both sides by 8. We end up getting x is less or equal to 4. Then from this stage, it is where we use the knowledge of the previous lesson and we represent our answer on a number line. That is my number line, less or equal to 4. 4 is included, that's why I'm making it closed, as we saw in the previous. Then another example, solve the inequality below and show the answer on a number line. Here we also divide both sides by 3. We want to make x the subject, but remember we have an inequality symbol, not an equal sign. Don't make a mistake and you change this one to an equal sign. We end up getting x is greater than 13. We are required to represent it on a number line. X is greater than 13. You've seen I've used an open circle, then all values greater than 13 are the solutions of x. Then another example here, solve the inequality below and show the answer on a number line. My first step here, I will add 5 both sides. I want to eliminate this 5. I'm adding 5 here and 5 this side. When you get 5 plus negative 5 here, you get 0. You remain with 3x. Then when you add 5 here, you get 24. Then the next step here, we divide both sides by 3. We end up getting x greater than 8. Then similarly, we represent it on a number line. It is an open circle there like that. Then there is another example here, solve the inequality below and show the answer on a number line. 6x plus 6 less or equal to 36. What do? We have to leave this x on the left side and we take the rest to the other side. I'm subtracting 6 both sides, minus 6 minus 6. Then 6 minus 6, I get a 0, I remain with 6x. Then 36 minus 6, you get 30. The next step here, I will divide both sides by 6. I end up getting x is less or equal to 5. Then I represent it on a number line. Another example here, solve the inequality and show the answer on a number line. Now this one, I can first try, I collect like terms. The way we solve equations, there is nothing new here. The way we solve equations, I'm collecting like terms. I want to bring this x. I want to bring this x close to this side. What should I do? I add both sides by 2. I add 2x both sides. I end up getting 7x. Because I'm adding x here to get 7x. When you add x here, you get a 0. 7x plus 3 is greater or equal to 10. Then I subtract 3 both sides. I remain with 7x is greater or equal to 7. Then the next step, I divide both sides by 7. I end up getting x is greater or equal to 1. Then we are required to represent it on the number line. That is the representation on the number line. Then another similar example here is, now we have 2 signs, x8. Write down the integers that satisfy this inequality. 8 is less or equal to 4x, less or equal to 20. You must make sure that the value here, it is just 1. 4x, we need to remain with x here, and then we try to write the solution set. Then the first step here, I'm dividing by 4 both sides. When I divide by 4 here, and I divide by 4, and I divide by 4. Aim, I want to remain with x here. That is the aim of the reason why I'm dividing by 4. Here when you divide, you get x is less than 20 by 4. You get 5, then here 2. 2 is less or equal to x, less or equal to 5. They want us to write the solution, write down the integers that satisfy this inequality. The best idea here is to first represent it on a number line, and then I try to write the integers. You can see 2 is inclusive. I have 3, 4, 5 is not included. There is an open circle here, coming from this symbol here. Then the integers that satisfy this inequality are 2, 3, 4. I'm meaning whole numbers. Integers are whole numbers. Then there is a trap which you need to note, such that you're not caught in this trap. When you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol to maintain a true statement. For example, I have negative x is less than 4. Negative x is less than 4. When you divide both sides by a negative, by -1, you will have x, assume you don't know the symbol, -4. You look here, I'm trying to explain this. Now you have negative x is less than 4. Now here, if they want you to write the values of negative x here, negative x is less than 4. And when you have this, something is less than, you have negative. When assume you have less here, this, let me remove this. You have x is less than -4, but you know by interpretation x is greater than -x. It's like you have -2 and 2. Which one is greater? Now, when you say this one is less than 4, then you again say that this one is less than -4. If they want you to use true or false, you can see here -2 is less than 4, but 2 is not less than -4. We've divided both sides by a negative to get this. Therefore, to maintain the true statement, after dividing by a negative or multiplying an inequality by a negative, we change the symbol. If it was less, it becomes greater than. If it was less or equal to, it becomes greater or equal to, and vice versa. Hope now you will not be caught up in the trap. We are together. Let's look at an example, and a simple one. Let's look at an example. Negative x is less or equal to 4. Multiply each side by the same number and reverse the inequality symbol. That's what we do. I'm multiplying by negative 1 throughout to get x is greater or equal to negative 4. See the switch, less than has become greater than. We change the symbol to maintain the true statement. We don't want to change the meaning, as I've explained. Then I have another example here. Negative 2x is less or equal to 6. We divide both sides by negative. Divide each side by the same negative number and reverse the inequality symbol. I'm dividing by negative 2 throughout, and I've reversed. It is less or equal to. Now I've reversed it to greater or equal to. Now you can see, if you have negative, assume you divided by x, you will have negative x is less or equal to 6. And when you divide by, there is a negative here, please. And when you divide by negative, you will have x, maybe you don't know the symbol, then negative 6. You can see now, negative x is less or equal to 6. Then if you divide, you can't say x is less or equal to 3 by to 3, since we've divided by 2. Then you can't say x is greater or equal to 3. We've divided by a negative. To maintain the true statement, we reverse the inequality symbol. Let's look at some examples. Write down the integers that satisfy this inequality. The first step, we collect like terms. I'm trying to remove this 1. I'm adding 1 on both sides. When you add 1 here, you get 0. When you add 1 here, you get 9. When you add 1 here, you get 4. Then from there, you represent on a number line, but that one has no negative. Let me pick the one with a negative. Solve the inequality below and show the answer on a number line. Now, I want to leave this one as a positive. I divide both sides by negative 1. I have x is less than negative 4. Of course, when you multiply or divide an inequality by a negative, you must reverse the sign. I repeat, when you multiply or divide an inequality by a negative, you must reverse the sign. That is our trap. Don't be caught up in the trap, since I've warned you. Then there is a last example here. Solve the inequality and show the answer on a number line. Similarly, we collect like terms. I'm trying to take this 2x this side. I will have 6 is less or equal to negative 3x. Then I divide by negative 3 both sides. Remember, when we divide or multiply an inequality by a negative, we must reverse the sign. Then I will have negative 2 is greater or equal to x. You've seen the reverse. Now, if you start with x, you'll have x is less or equal to negative 2. Thanks for watching.